to first exercise 1.1, class 11, CBSE first chapter sets. So question 1, which of the following assets justify your answer? So here you can see the first problem is the collection of all months of a year beginning with the letter J. This is very well defined because we know what are all the months which are beginning with the letter J. So here in the solution you can see here the collection of all months of a year beginning with the letter J is well defined collection of objects, and those objects are nothing but, or elements are January, June and July. These 3 months are starting with letter J. So since this is very well defined, since one can identify a month which belongs to this collection, therefore this collection is a well defined set. Next, second one, the collection of 10 most talented writers of India. So now collection of 10 most talented writers of India. Now in this collection, the 10 most talented writers for me might be different from the 10 most talented writers of India for you. So it differ from person to person. Therefore this is not a set. Therefore you can write that the collection of 10 most talented writers of India is not a well defined collection, as the criteria to determine who is most talented may differ from person to person. Therefore this collection is not a set. Now going into the third one, a team of 11 best cricket batsmen of the world. Now again the 11 best cricket batsmen of the world might differ from person to person. It might be different for me, for you it might be different, for someone else it might be different, for all the students in your class it might be different. So therefore a team of 11, it is not a set. So therefore a team of 11 best cricket batsmen of the world is not a well defined collection, as the criteria to determine who is the best cricket batsman may differ from person to person. So therefore this collection is not a set. So let's go into the next one, the collection of all boys in your class. So now the collection of all boys in your class are well defined. Whether they are at any place, they are collection of your class. So you know that that boy is from your class. Therefore this set is a well defined set. So the collection of all boys in your class is a well defined collection, as one can identify a boy of his class or a particular class who belongs to this collection. Therefore this collection is a set. Now going into the fifth one, the collection of all natural numbers less than 100. This is also very well defined, because you know all the numbers, 99 numbers which are natural numbers, which start from 1 to 1. All the numbers which are less than 100 are 99 numbers are there. Therefore this is a very well defined collection of sets. So the collection of all natural numbers less than 100 is a well defined collection, as one can find a number which belongs to the collection, that is a number less than 100. So 99 numbers are there. Therefore this collection is a set. Next one, now a collection of novels written by the writer Munshi Premchand. So you know all the novels which are written by this writer Munshi Premchand, and this is a very well defined set, because if you take a book from any library and you see there that this is the author, so it is a collection from his collection, Munshi Premchand. So therefore the collection of novels written by Munshi Premchand is well defined collection, because therefore this collection is a set. So you can identify from different books what Munshi Premchand has written. So therefore this is very well defined. Next, the collection of all even integers. So you know what are all the even integers. So therefore the collection of all even integers is a well defined collection. If we consider an integer, we can find whether it belongs to the set of collection or not. So this collection is a set. So therefore whether it belongs to the set means even integers, whatever we take, we can take a negative one or a positive. So all even integers which are multiples of 2, even or positive, all belongs to this collection of set. Next one, what's the eighth one? The collection of questions in this chapter. So definitely you'll know what are all the questions. If you take a question from the chapter sets, you know which question is from which chapter. So this question belongs to the chapter sets. If you are aware of the chapter, so definitely you'll know that this the collection of questions in the chapter is a well defined collection, as one can find a question which belongs to this collection. Therefore this collection is a well defined, is a set. Next, last one in this first question. A collection of the most dangerous animals of the world. So, collection of most dangerous animals. Now, this dangerous means it is again different. For one, even lizard looks dangerous. So, therefore, we cannot tell which is dangerous. For some, frog is also dangerous. When they see the frog or lizard, they don't at all move in that place. So, it is the collection of most dangerous animals of the world is not a well defined set of collection, as the criteria to determine which animal is dangerous may differ from person to person. Therefore, this collection is not a set. Let A equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs or does not belong in the blank spaces. So now over here you can see in this first bit over here, you can see second question. Let A be equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belong or does not belong in the blank spaces. So the first one, you can see that 5 dash A. So does 5 belongs to the set A? It is there in the set. So this is denoted as belongs to. So you can see the 5 belongs to set A. Next, second one is 8 dash A. 8 does not belong to set A because it is not there in this 1, 2, 3, 4, 5, 6. Then third one, look into the third one. What's the third one? 0 does not belong to the set A because it's not there. Then fourth one, 4 belongs to set A. Then fifth one, 2 also belongs to set A. Then 6, 10 does not belong to set A. So you can easily find out what are all the elements of this set A. So next, we'll go to the next question. This is our next question, third one. So in this question, you can see write the following sets in roster form. It's given in set builder form. We have to write this set in roster form. So how can we write this? We'll just see. So what all are given here? A is equal to x such that x is an integer and x lies between -3 and 7. So now this you have to write it in roster form, means the first one. So you know that x is an integer. So x is an integer means you can tell that all integers, you know that it lies between -infinity and infinity. So therefore A is equal to, it consists of all the elements, because here it is given as -3 less than x less than 7 means -3 is not in that it doesn't lie in this interval. So it is a closed, it is an open interval, -3 and 7. So -3 is not included, 7 is not included. So what are all the numbers left out? -2, -1, 0, 1, 2, 3, 4, 5 and 6. So these are the numbers which are only elements of this set. So this is the way you write it in the roster form. Next, it's given in the set builder form, we are writing in the roster form. Next, B is equal to set x is a natural number less than 6. Now what you have to do, in my video you can see the previous video I have given the basics concepts of sets. You can go into the description, look into the link and you can follow those steps, wherein how to write in roster form and how to write in set builder form I have shown over there. Now here B is equal to x such that x is a natural number less than 6. So less than natural number less than 6 means natural numbers start with 1. So 1, 2, 3, 4 and 5. So this is the set which is of B, which consists of all natural numbers less than 6. So what you have to check over here is each and every element of this, whether it belongs to the set or not. When you're taking 1, does it belongs to 6? Does it belong to natural number less than 6? When you're taking 2, does it belong to a natural number less than 6? 3, does it belong to a natural number less than 6? So still where we are taking till 5. 5 is a natural number less than 6. So we are taking all these elements. Next, The third one what we are having, C is equal to set of x such that x is a 2-digit natural number such that the sum of its digits is 8. So sum of it's a 2-digit number where the sum of these digits is 8. So now you can take 17, when you add both the digits it's equal to 8. Then 26, 35, 44, 53, 62, 71. Now you can see after 44 we wrote the reverse of all these numbers, 35, 53, 26, 62, 17, 71. So all these numbers, when you add these digits, you can see the sum of these digits is nothing but 8. So next, fourth one, D is equal to set of all x such that x is a prime number which is divisible by which is a divisor of 60. So now we are divisor of 60. What are all the factors of 60 we can see from here? You can just take the LCM and see here. You can 2 30s are, 2 15s are, 3 5s are, 5 1s are. So here you can see 60 can be written as equal to 2 into 2 into 3 into 5. So when you are writing it as a set, you know that set will never have repeated numbers. So it consists of what divisors 2, 3 and 5. 2 is repeated twice, but we write it as only 1 because 2, this whatever divisors we are writing of 60, does it belong to set D or not, we have to see. So D, if you define as 2, 3, 5, you can see that all these divisors belong to the set D. Next, fifth one here, E is the set of all letters in the word trigonometry. So in the word trigonometry, you can see that trigonometry. So it consists of 12 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now what all alphabets are there in the set we have to see. So now when you are writing it from the beginning, T, comma R, comma I, comma G, comma O, comma N. Now again O is come. So O is already there in the set, so you cannot repeat it. Then you can write it as M. Then you can write it as E. Now T is already there, R is already there, then you write it as Y. So totally you have all these T, R, I, G, O, N, M, E, Y. All these elements are of this set, so that you can see whether T, when this trigonometry, when you read this word or when you check this word, you have to see whether all these letters are in this set or not. That is set E. Then you can tell this is written in roster form. That means the set of all letters in the word trigonometry. Then last one, sixth one in this third question is the set of all letters in the word better. So now sixth one, F, it is defined as F. So better, how do we write this? B you can consider, E you can consider, T. Now again T is repeated, E is repeated. So what does this consist of? This set B, E, T, R. This is the set. So now next, this is the way we write set builder form in roster form. Right, the previous one was we have to write that what was given in set builder form in roster form. Now we have to write what is given in roster form, we have to write it in set builder form. So now how do we do this? We'll just see. So now what is given over here? The first question is under question 4, write the following sets in the set builder form. 3, 6, 9, 12 is given. So now what is this 3, 6, 9, 12? There's some common factor for this, isn't it? So 3, they are multiples of 3. See, 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. You can either write it as 3n less than or equal to where you can define n also. You can define n also, or you can write multiples of 3 less than or equal to 15. That also you can write. So you can define the set as A. It is set of all x such that x is equal to 3n and n belongs to set of natural numbers and n lies between 1 and 4. You can write this, or you can write x such that, or x is a multiple of 3 less than 15. So you can see 3, is it a multiple of 3? 3, yes. Then 6, is it a multiple of 3? Yes. 9, is it a multiple of 3 less than 15? Yes. 12, is it a multiple of 3 less than 15? Yes. So therefore you can see whether all these elements whichever I have written here is belonging to that set, roster form set. Now the second one, how do we define the second one? We'll see. We can name it as B. Now B, what is given over here? You can see that it is 2, 2 square, 2 cubed, 2 to the power of 4, 2 to the power of 5. So all these, it is power of 2. So here you can write this as set of all x such that x is equal to 2 to the power of n, where n belongs to set of natural numbers, and n, the small n, lies between 1 and 5. So it is less than or equal to 1 or less than or equal to 5, because you are having 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is equal to 8, 2 to the power of 4 is equal to 16, 2 to the power of 5 is equal to 32. Next, third one. What's the third one? The third one, you can see it is 5, 5 square, 5 cube, 620, 5 to the power of 4. So therefore here you can write this as set, you can name it as C is equal to set of all x such that x is equal to 5 to the power of n, where n belongs to capital N and n lies between 1 and 4. It's equal, 1 is less than or equal to n, less than or equal to 4, because you know that 5 to the power of 1 is equal to 5, 5 to the power of 2 is equal to 25, 5 to the power of 3 is equal to 125, 5 to the power of 4 is equal to 625. Next, fourth one, 2, 4, 6 and so on. So these are all even natural numbers. So therefore you can write this as D, you can define the set as D. It is equal x such that x belongs to, x is an even natural number. You can write even natural number, or you can also write it as x is equal to 2n, where n belongs to set of natural numbers. Next, fifth one. What's the fifth one? We'll see. Fifth one, it's given as 1, 4, 9. Perfect squares are given. That is 1 square. So you can name this as E, which is equal to, you can write this as set of all x such that x is equal to n square, and what is the last number which we are having? 100. So it is 10 square. So n lies between, it's not between, it is less than or equal to 1, less than or equal to n, less than or equal to 10. So therefore you can see this, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and so on, up till 10 square is equal to 100. So this is our fourth problem. Now let's go to the fifth one. List all the elements of the sets, the following sets. So we have to write what are all there in this set. So therefore the first one is given as A equal to x such that x is an odd natural number. Odd natural number means, you know that you can name this is already given. A is equal to odd natural number. Odd number starts with 1. 1 is an odd number, so natural number it is. So 1, 3, 5, 7, 9 and so on. Next, B bit. I'm sorry, second one, b is equal to set b is equal to set of all x such that x is an integer. So what's given, we are defined with x lies between minus 1 by 2 and 9 by 2. So here you can tell that it lies between minus 0.5 and less than x less than 4.5. So here you have to tell that x is an integer. So integer, you don't have decimal points, so you can tell that here after 0.5, here you can get it as, so this 0 minus 0.5 less than 0 less than 1 less than 2 less than 3 less than 4 less than 4.5. It is not including these minus 0.5 and 4.5. So what is given in the question, b is equal to set of all x such that x is an integer which lies between minus 1 by 2 is less than x less than 9 by 2. So we have to search for integers. You know that it doesn't consist of 0.5 terms, that is decimal point terms. So therefore minus 0.5 is less than x less than 4.5. So you can write this as minus 0.5 is less than 0. All the integers I have written here. So these are the integers between these numbers. So you can write here 0, 1, 2, 3 and 4. This is the set which is defined over there. Next, going into the third one, what's the third one? We'll see. Third one, c is defined as x such that x is an integer, x square is less than or equal to 4. So x is an integer and it is less than or equal to 4 means we have to take integers. You know that x square, it is given as x square. So therefore we know that c is equal to, we can see that x square is less than or equal to 4. It means that minus 1 whole square is equal to 1, which is less than 4. Then you can take minus 2 whole square is equal to 4, which is less than or equal to 4. So therefore minus 3 whole square, now you can take even 1 square is equal to 1, which is less than or equal to 4. 2 square is also equal to 4, which is less than or equal to 4. So we have even 0 square is equal to 0, which is less than or equal to 4. But you cannot take minus 3 whole square, which is equal to 9, is less than, it is not less than or equal to 4. Even 3 square is equal to 9, it is not less than or equal to 4. So what all elements come in this, we'll just see. It's right, you can write it as 1 minus 1, I'm sorry, minus 2 is also there. So minus 2, minus 1, 0, 1, comma 2. So these are all the elements which lie in this, because it's consisting of set of integers. Next, D is the set such that x, it's defined in such a way that x is a letter in the word loyal. So loyal, what all consists in this? We have in the set L is repeated twice, so you can see that and just write it down. So what all are defined in the set D is equal to L comma O comma Y comma A. These are all the elements of this set. Because L is repeated twice, you can take it only once, so therefore you're writing it in this. Next, X is a month of a year not having 31 days. So we have to write all those months which do not have year which is not consisting of 31 days. So first we can see that which month doesn't consist. E, you know that which all months do not consist. So it is February. Again March has, then April won't have, then June won't have, then June, July, August, July and August will have, then September, and then November. So all these won't have 31 days. Next, sixth one. What's the sixth one? We'll see. F is equal to X such that X is a consonant in the English alphabet which precedes K. So consonants are all those which are not vowels. We don't have vowels in them. Other than vowels, all those alphabets are consonants. So now, which precedes K. Precedes K means which is less than or equal to K. So we have to write all those alphabets other than vowels which are consonants. So which is equal to B, C, D, again E is a vowel. So F, G, H, I is again J is there. Then you're having K. So these are all the alphabets which precedes K. So these are the elements of the set. Next, this match each of the set on the left in the roster form with the same set on the right described in set builder form. So we have to match these onto the right. So here first one 1 2 3 6. So here we have to see it matches with which. How we can write this roster form in set builder form, we have to see. So now here we'll read all this. This x is a prime number and a divisor of 6. No, that it doesn't satisfy that. Then x is an odd number. Okay, we'll just one. It consists of all elements 1 2 3 6. This is here the elements of this set are, okay, we'll not take all this natural numbers. The first condition is that, and they're having numbers 1 2 3 6. So they're all the divisors of 6. So anything of that sort is the yes, it is matching with C. So it matches with C is the correct answer. That is equal to set of all x such that x is a natural number and divisor of 6. Next, second one. So 2 3. So 2 3 are, these two are prime numbers. You can see it's defined like this. It is a prime number and also they are divisors of 6. So therefore it matches with A. So this is equal to set of all x such that x is a prime number and a divisor of 6 and a divisor of 6. So this is it. Now third one, in this what's given, mathematics, MATHEICS. Now we can see that it is a letter of the word mathematics. It's very obvious so there. So here MATHEICS. So this is nothing but D, which is equal to x such that x is a letter of the word mathematics. So x such that x is a letter of the word mathematics. Yeah, next the fourth one. What's the fourth one given? 1 3 5 7 9. There's only one left over there. Is an odd number less than natural number less than 10. So 1 3 5 7 9. It is matching with B. That's only the one match left out. So this is 1 3 5 7 9 is matching with B, which is equal to set of all x such that x is an odd natural number, is a odd natural number less than 10. So this is the first exercise. So then we will come up with second exercise after this.